Very good morning to all. I welcome you all for today's session, Transistor Logic. We used to name it as TTL. So Transistor Logic. In digital logic family, that uses transistors. Our digital logic family, all devices uses transistors for both logic and amplifications. So transistors has both input and outputs, then diodes, resistors. Transistors are widely used in computer controls, consumer electronics, industrial systems. The key feature of a transistor is it performs both logic and amplification functions. Unlike resistors, transistor logic or TL and diode, then transistor logic DTL. Resistor transistor logic and diode transistor logic like OTL and DTL. So here these are the subfamilies of transistors like fast TTL, high power TTL, advanced Schottky TTL, then Schottky TTL. There are so many sub-transistors logic families which includes such different type of families like all fast, high, slow, advanced, normal, then low power, high power, all type of sub-transistor logic family. So the transistor logic gate circuit here shows the two input TTL NAND gate. It has 4 transistors from Q1, Q2, Q3, Q4. Transistor Q1 has 2 inputs. In this circuit we can see 4 transistors like Q1, Q2, Q3, Q4. So this Q1, transistors Q1 has 2 inputs on the emitter side, and transistor Q3 and Q4 here form a totem pole output, that is your Y output. So the inputs A and B are low when both the diodes are here when it is biased. So this is a 2 input TTL NAND gate. That is 2 input transistor logic NAND gate. So the current due to the supply voltage, see we can see A, B inputs and VCC and Q3 and Q4, sorry Q2 and Q4 is grounded here. In this emitter is grounded, and in Q2 resistance is connected in the ground connection, and in all the transistors a resistance here is connected. Okay, so the current due to the supply voltage plus VCC is equal to 5 volt. This will go to the ground through R1 and the 2 diodes DA and DB. So the supply voltage gets dropped in the resistor R1 and it will not be sufficient to turn on the transistor Q2. It will not be sufficient to turn on the transistor Q2. So the transistor Q4 will also cut off, but the transistor Q3 is pulled high. Since Q3 is pulled to the lower, the output at the terminal will also be high, which it is at logic 1. So logic 1 means high and logic 0 means low. So the input section either A or B is low. The diode with low input will be forward bias. So the operation will take place as explained above. In this case, the output will be very high. So altogether, the inputs A and B are high. Both the diodes at the emitter base junction will be reverse biased. The diode DC at the collector base junction is forward biased. It will turn on the transistor Q2 with Q2 turned on, and transistor Q4 will also be turned on. Both the transistors at the output side will conduct, and so the output at terminal will have low value, which is considered as logic 0. So the configurations of TTL are, there are 3 different output configurations in transistor logic, like totem pole output, open collector output and tri-state gate output. So these outputs, each output you have different type of circuits, like this is for totem pole output, which is given here. You can see during the transition the load capacitance across Q3 charges exponentially from low to a high voltage. And this is the transistor output logic circuit. Here we have an external pull-up resistor to bring out our output. That is, the output is taken from the open collector terminal of Q4. And another one, gate output. Here the output is low when the transistor Q4 is turned on. The first and second states are the normal operation of the TTL. In this third state, both transistor Q3 and Q4 are turned off. So these are all about transistor and the advantages of transistor logic circuits. These are all the advantages, like it has better fan out, can drive more inputs, reliable operation in noisy environments, robust noise immunity. These are the advantages of transistors. So thank you. We'll see in the next section.